Okay, we started chapter 5 right before the break. That was where we learned the cheer, sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. So those of you who are behind, there are about 4 of you that didn't do that assignment. So you'll need to get caught up on that. Watch the video if you need to. What we're going to do today is we're going to talk about something called an identity. So an identity, think of like an identical, right? You know, many of you know that Miss Price is an identical twin, right? And when they were here at Valley, we didn't have uniforms or anything, but they would dress in the same clothes and then attend the opposite person's classes. Right? So like Miss Price was the one who was good at math, so she would maybe go to math in her sister's place. She'll tell stories about this. Okay, so the teachers had to be really on it to know, who was who. Was it Carrie or is it Donna? So that they would switch out. Okay, they would swap places with each other. So it's kind of like that with what's called a trig identity. There are some things that are identical in trig, and you can swap their places when it's advantageous. Okay, when one is better than the other, then you trade places. So here's some of the things that are identical to each other. All right, so these are called the main identities. And some of you know already, tangent of x. We already know that tangent of x is the same as or identical to sine of x over cosine of x. We've learned that. I can't remember what day we learned that, but we've known that for like a month and a half already, that is an identity, that is true. Those two things are equal. They are identical. So in the same way, what is cotangent identical to? So which would be the reciprocal, which is cosine over sine. All right, so we know that those things are true. Okay, they are identical. So think about Miss Price and her twins swapping places in class. This would be true too in this situation. If you saw a tangent in a problem, you could swap it out with its identical twin, sine over cosine, because there might be an advantage to that. Another one that we've learned already is cosecant. Cosecant is identical to 1 over sine of x. It is the reciprocal, and so you put a 1 over, and then those are identical. We've also learned that secant is 1 over cosine of x. So these are 4 that you already know. And so I'm going to show you some sample problems with those 4. Then I'm going to teach you some new ones that you don't know yet, that you haven't seen. But let's practice with the ones we do know. So what I'm going to do is just sort of show that these are important by putting a box around it, and then we'll do some sample problems. Okay, the whole idea is to replace one with the other and then reduce if you can. Okay, replace and reduce. Just keep kind of thinking that. I need to replace first, and then I need to reduce. So here's how a problem might look. You might start with the problem cosine of x multiplied by tangent of x. Okay, that might be your question. Well, we know that tangent has an identical twin. Okay, so this tangent right here has something that I could change it with. I could swap places. And so what you want to do is put an equal sign to show that they're still equal, they're identical. And cosine of x times, and then you replace, thank you, you replace tangent with its identical twin. And its identical twin is sine of x over cosine of x. So that's the replace step. The step that comes after replace is reduce. And it should be obvious to you what two things reduce each other. Cosine, because there's a cosine in the numerator and then multiplied by cosine in the denominator. Just like if we would have numbers, like a 2 on the top and a 2 on the bottom or whatever, they would reduce. And so cosine reduces away, and you're left with sine of x as your answer. That's it. It's simpler. It was advantageous to switch tangent with its identical twin because then I could reduce and I'd be left with an easier answer than to answer the problem. The whole idea is to take a problem and make it simpler at the end. The final result should be a more simple version of what you started with. All right, so that was a basic one. Let's try another one. Replace, reduce, replace, reduce. All right, so secant of x divided by cosecant of x. Okay, so now we're going to do the mantra replace and reduce again. And so I can replace secant x with its identical twin, which is what? And you can look back at your notes if you want. 1 over cosine. All right, divided by. And then I'm going to replace cosecant x with its identical twin, or identity, which is 1 over sine. Okay, so I did replacing twice. So it should be replace and reduce. Now, is there anything I can reduce here? Is there anything that's in the numerator and the denominator that I could cross out? Not a trick question. The answer is no. If the answer is no, that means you're not done replacing. There should be something else we can replace. Well, we replaced secant, we replaced cosecant. What's the only thing we haven't replaced? Like literally, the division sign. And that's the last replacement we're going to make. Okay, we're going to replace division. Because division is the same as or equal to something you learned back in elementary school. What is division the same as? Multiplying by the reciprocal. So replace it. All right, so then equals, I always show equals to show that these are still the same. 1 over cosine of x is going to, now the division sign is going to get replaced. And it's going to get replaced with a multiplication sign, followed by the reciprocal of 1 over sine, which is sine over 1. And then I ask myself, okay, now can I reduce? Now is there something in the numerator and the denominator that I can cross out? And now the answer is yes. So until the answer is yes, I can reduce, you got to keep looking for something to replace. And so the 1s reduce away. And the only thing that you're left with in the numerator is sine of x. And the only thing you're left with in the denominator is cosine of x. And sine of x over cosine of x has an identity as well, which is tan. And that's the most simple. I can't get any simpler than that. That is as simple as it could get. So I started with a problem that had 2 parts with a division sign, and it ended up just being equal to tangent. Okay, I've got one more in this section. Okay, so we have tangent of x divided by secant of x. All right, and a problem that's set up like this. Okay, so let's kind of look back at what we've had. The first question, oops. Okay, the first question was a multiplication problem. The second question was a division problem. The third question is a fraction. Okay, when you have a fraction question, the first thing you want to replace is this division fraction. And you want to replace it with the dot dot division symbol, okay, where you have a line with a dot over it. So that would be the first thing I want to replace. So we're just going to keep replacing, but that's the very first thing. So I'm going to replace this with tan x, and then I'm going to change this to a division dot to dot. I don't know what the official name of that is. And then secant x. So that's the first replacing that I do. The next replacing is with the identities for both tangent and secant of x. So tangent is sine of x over cosine of x. And still division. And then secant is 1 over cosine of x. So I've done the replacing of the fraction bar, and I've done replacing of the tangent expression and a replacing of the secant expression. But I'm still not ready to reduce. So if I'm not ready to reduce, there must be another replacing to do. And the replacing I want to do is with now that division. So I'll change that. keep the front part the same and change the division to a multiplication, and then change what comes after that to the reciprocal, which would be cos of x over the number 1. And now I'm ready for the reducing step. So I did several replacings. In fact, I did 4. I did a replacing of the fraction bar, I did a replacing of tangent, a replacing of secant, and then a replacing of the division dot-to-dot part. Now I'm ready to reduce. So cosine on the top, cosine on the bottom. I am left with equals sine of x, and then over 1, which isn't really necessary. You don't have to put the over 1 part. You could just put sine of x, and that would be fine. All right, so any questions so far? It's easy because you know these identities already. All right, let me give you the next category of things that are identical twins, okay, that are identities with each other. Those are called the main identities we just did. The next ones are called the reflection identities. All right, so dare I say the bad word, but I've been graphing. What reflects something? How do you know something will be reflected? Say it. Negative. It has a negative, okay? So these are going to have negatives in them. Okay, here they are. Sine negative x, tan negative x, cosecant negative x. These 3 have identical twins. Okay, sine negative x, tan negative x, and cosecant negative x. All right, these 3 become the negative on the outside. Negative sine of regular x, negative tan of regular x, and negative cosecant of regular x. It's almost like you take the negative and you spit it out to the front, and that's where they go. These are identical twins. So you can swap them out. They can trade places with each other. What about the other 3? So we did these 3, sine, tangent, and cosecant. What about the other 3? Okay, well they kind of come as a group. So those are your first 3, and then you've got 3 more. So what about cosine negative x? What about cotangent negative x? And what about secant of negative x? So what about those 3? Do they have something that they're identical to as well? And the answer is yes. But the difference with these is that they're equal to their positive self, not their negative self. Cosine, cotangent, and secant are all equal to their positive. So in those 3, you can take their negative versions and replace them with their positive versions. And it only works for those 3. For the first 3 we did, so they definitely come in sections. For the first 3 here, they spit the negative out. So if there's a negative in, there's a negative out. For the second set of 3, if there's a negative in, it's like it's an absolute value. The reason it has to do with the way the graph is shaped and the fact that these graphs are symmetric over the y-axis. That's why that's true. But if you just remember that those 3 are the absolute values of themselves. Okay, and those are called the reflection identities. And so you're still going to replace and reduce with those 6. So it'll look like this. All right, so maybe this says simplify the following problem. Cosecant negative x divided by cotangent negative x. So replace, reduce. So keep replacing until you can reduce. Okay, well, let's look at the first one, cosecant of negative x. Do I replace that with its positive self or its negative self? its negative self. Okay, I'm going to replace that with its negative self, which is negative cosecant of x. So that's the rule for that one. Divided by, then I go on to cotangent. Cotangent falls into the category that it gets replaced with its positive self. And so that would get replaced with positive cotangent of x. So that was the first step, is to replace, in one of them, replace it with its negative self, and the other replace it with its absolute value self. Now I do the same thing I did in the previous questions. All right, so that negative has to stay there. But now cosecant gets replaced with 1 over sine of x, because that's its definition. And divided by, and cotangent gets replaced with cosine over sine. Have I done enough to be at the point where I can reduce? Not yet. And so I need to replace something else, which would be the division symbol in the middle. So I'll replace that, 1 over sine of x, and I'll replace that with a times. And then I'll flip the second one that comes after it. So then I say, well, now have I done enough that I can reduce? Have I replaced enough things that I can reduce? And hopefully now you see that the signs can be reduced. The numerator sign can get reduced with the denominator sign. So let's put together what we have left. I have a negative, I have a 1 on the top, and I have a cosine of x on the bottom. And is there any last replacement that I can do? Do you see what that is? Yeah, 1 over cosine itself has an identical twin. And its identical twin is negative, since the negative was still there, secant of x. That's as simple as I can make this. I can't make it any simpler than it was. So I stop there. Okay, I want to do another one of these with these negatives. Okay, next one we're going to do is secant of negative x. Oops. Times cosine of negative x. Okay, so I'll deal with the negatives. Both of these belong to the category where they would become their positive self. Okay, they would become the absolute value. So secant of negative x can get replaced with secant of positive x. Cosine of negative x is the identical twin of cosine of positive x. They are identical to each other. But I still can't reduce anything. And so then I have to replace secant with its main identity of 1 over cosine. All right, so I've done replaced one of the negatives, replaced the other negative, and then I still couldn't reduce. So then I replaced secant with its main identity, and I said, oh, now can I reduce? And the answer is, yep, now I can reduce. There's a cosine in the denominator and a cosine in the numerator, and all I'm left with this time is the number 1. Okay, that's it. Okay, any questions on those so far? Okay, then we only have one other group of identities. So we have the reflection identities. So what else do we do to graphs besides reflecting them? Great, and that's the last set of identities, are the shift identities. And you actually already know some of these already too. Okay. All right, the sign of pi halves minus x. and the cosine of pi halves minus x. These are both shifted. Shifted what direction? What do you think? What direction? Why? Ooh. The way it's given is not in the right order. This is sine of negative x plus pi halves, right? That's actually, the negative is with the x. So what does the negative actually mean? Negative means a reflection, right? So what direction? Because this is plus pi halves. Right, this is left. What happens when you take a sine graph and you move it to the left? You get a cosine graph. That's what we learned before spring break. Because when you start with a sine graph and you slide it over, now it's a cosine graph. All right, so that's the identical twin for this one. I can erase that. I don't need that. That sine shifted is the identical twin of cosine. What's nice is that when cosine is also shifted, its identical twin is sine. It's fantastic like that those work out. But the shift has to be pi halves. This does not work with pi fourths or pi thirds or pi sixths or any other pi number. It has to be pi halves. The book will call these co-function identities. I don't like the word co-function. I guess I don't have anything against it, but I feel like a shift helps me picture that what it's doing. Co-function doesn't really mean anything to me, but shift, I know what shift means. And so the shift identities is that sine with a pi half shift is a cosine graph, and cosine with a pi half shift is a sine graph. And the nice thing is that it works perfectly for all the other pairs of functions. So if you have cosecant or secant, and the shift is pi halves, it has to be pi halves. Sorry, Emma. Then they are shifting into each other as well. So cosecant shifts right into secant, and secant shifts right into cosecant. But I can't stress enough that this only works for pi halves. So there's got to be a final pair, and that's tangent on a pi halves shift and cotangent on a pi halves shift. And those shift into each other as well. So these are called the shift identities. There are 6 of them, but there's basically 3 pairs of 2. And so I'll put my last box around that as the last. So we started with the main ones, we learned the reflection ones, and now we finish off with the shift ones. And so I'll show you 2 examples of that, and then you can start your homework. The whole point of all of these is to make a substitution, make a switch with the identical twin, so that it's to your advantage. Just keep remembering that the Price sisters, if they would switch, it would be switching so that the smart person was in the class that they were smarter in, whether it was history or English or science or math or whatever. Okay? So you do it with intentionality. All right, so cotangent of pi halves minus x times cosine of negative x. I would think it would even be easier today with uniforms. They haven't been the only sets of identical twins we've had come through. I can think of 3 others off that but there might be more. Okay, so here we're looking at, all right, what can I do? So I see this as a shift identity. So I will swap it out, and I look cotangent on a pi halves shift can get replaced with the identical tangent x times And then I look at cosine of a negative x, which is the reflection identity from before, and that belongs to the groups that become their positive selves. And so I drop the negative. But I can't reduce yet, so it means there still must be more replacing to do. So you tell me, what replacing can I do now? Tangent. What can tangent get replaced with? All right, so sine over cosine, and still multiplied by cosine. And I know I did the right thing because now I can reduce. And so cosine will reduce. And I'm left with sine of x all by itself. And that's the most simple version of that question. Okay, last one. All right, sine of pi halves minus x multiplied by cosine of pi halves minus x. Two shift identities. Oh, whoops. It's supposed to be divided. Okay, two shift identities. And so sine as a shift identity changes into cosine divided by, now cosine as a shift identity changes into sine. So I did two replacings, but I still don't see anything I can reduce. So there must be some other replacement that I have to do. So you tell me, what other replacement can I do at this point? Okay, it's the division. Okay, that's the division I need to change. So you can change division in two ways. You can change it to multiply by the reciprocal, or you can change it back to a fraction. Whatever one. Okay, those are the same thing. And now cosine in the top and sine in the bottom is replaceable with its identical value of cotangent, because when cosine's on the top, and now you have it in its most simple form.